హలో హలో
సార్
వచ్చారా?
సార్
వచ్చింది. వెరీ వెరీ గుడ్ మార్నింగ్. ఒక 1 minute. English medium. Wait for 1 minute. Last class we are completed measures of central tendencies. Okay. Today we shall start measures of dispersion. Measures of dispersion. Isn't it? Okay, na? Yes, please. Anybody respond? So that is unit 5.
Yes, sir.
Unit 5. Range, quartile deviation, mean deviation, and standard deviation. That is the unit 5. This is the unit 5. On the screens, you will see the screen. Unit 5, range, quartile deviation, mean deviation, standard deviation. These are the 4 measures of central tendency. Measures of dispersion. So measures of dispersion, these are the 4. That is unit 5, range, quartile deviation, mean deviation, standard deviation. So what are the characteristics of an ideal measures of dispersion? Dispersion means whether the variable are very near to near or very far to far. దగ్గరగా ఉన్నాయా దూరంగా చెప్పేదాన్ని ఏమంటాం డిస్పర్షన్ అంటాం. సో హౌ ద వేరియబుల్స్ ఆర్ డిస్పర్స్డ్, whether it is less dispersion or whether it is more dispersion is known as dispersion. A good measure of dispersion should possess as far as possible the following characteristics. It should be simple to understand and easy to compute, and it should be readily defined. It should be based on all the observations. It should be amenable to further mathematical treatment. It should have sampling stability. It should not be unduly affected by extreme items. So these are the characteristics, various characteristics of an ideal measure of dispersion. Method of measuring dispersion: for ascertaining the deviations from the central value, there are certain specific measures of dispersion. The important measure of dispersions are range, quartile deviation, mean deviation, standard deviation. In measures of dispersion, various measures of dispersion can be classified into 2 categories. One is the measures which express the spread of observations in terms of distance between the values of the selected observations. These are also termed as distance measures, that is range and a quartile deviation. The measures which express the spread of observations in terms of the average of the deviations of observations from some central value, that is mean deviation, standard deviation. So these are the 2 mean deviation, standard deviation are known as So the measures which express the spread of observation in terms of average. So in that, absolute measures and relative measures of dispersions. So what are the absolute measures of dispersion? What are the relative measures of dispersion? Absolute measures of dispersion, nothing but you can get absolute value that indicating range, quartile deviation, mean deviation, standard deviation. Whereas when you're comparing the two series, we need not calculate measures of absolute measures of dispersion. We can calculate relative measures of dispersion. For that relative measures of dispersion, nothing but coefficient of range and coefficient of quartile deviation and coefficient of mean deviation and coefficient of standard deviation. So these are the four relative measures of dispersion. Okay, clear? Now coming to here, you can see range. So range, the simplest method of studying dispersion is defined as the difference between the value of the largest observation and the smallest observation included in the distribution. It is denoted by range. So range R is equal to, that is X maximum minus X minimum, or you can say L minus S, wherever L is equal to largest observation and S is equal to smallest observation. In the given individual series, you can find out the largest value identified. You can identify the smallest value. So largest value minus smallest value is known as, it is the range. A relative measure of range is called the coefficient of range and is given by coefficient of range is equal to L minus S by L plus S, wherever L is equal to largest observation and S is equal to smallest observation. So here I have taken one example. Find the range and coefficient of range for the following data: 10, 8, 5, 10, 9, 14, 7. So in that largest value is 14, isn't it? Yes, yes, students, give the response.
Yes, sir.
In that series, the largest in that series, the largest value is 14 and smallest value is 5. It is clear?
Yes.
Now range is equal to L minus S. That is 14 minus 5 is equal to 9. So 9 is the value of the range. It is the absolute value for the given data. Now, okay. Now second one is coefficient of range. So see, this is coefficient of range, nothing but that is the relative measures of dispersion, L minus S by L plus S. So 14 minus 5 by 14 plus 5 equal to 9 by 19. So here they will not give the simplification. So you can calculate 9 by 19. You should get the value. Okay. So this is known as range. So what are the measures? It is very easy. And it, in certain types of problems like quality control, weather forecasts, spare, price analysis, etc., range is most widely used. Demerits, it is very much affected by the extreme values. Only you can find the maximum value and you can find the lowest value. So you should not, you should forget the remaining values. You should forget the remaining value observations. It is based on only two extreme observations, that is known as maximum value and minimum value. It is not suitable for mathematical treatment. It is not at all a reliable measure of dispersion. So this is known as range. It is clear? Any doubt? Give the response.
No, sir.
Any doubt?
No, sir.
No. Now coming to second one is quartile deviation. Quartile deviation as a measure of dispersion has certain limitations. It is based on two extreme observations. For this reason, there have been developed a measure called the interquality range or quartile deviation. Okay. Now, quartile deviation is the whole data of observations into approximately 4 equal parts. Quarterly deviation is definitely a better measure than the range, as it makes use of
Excuse.
by Q3 plus Q1. One minute, screen is not visible. See here. That is quarter deviation Q3, that is the third quartile by 2. That nothing but Q3 minus Q1 by 2. Coefficient of quartile deviation Q3 minus Q1 by Q3 plus Q1. Here I have taken one example. Calculate quartile deviation and its coefficient for the following data: 20, 28, 40, 12, 30, 15, 50. Arrange the given observation in ascending order. See, quarters are time nothing but Q1, Q2, Q3, Q4. It is based upon the median. So when you are calculating quartiles or median or percentiles or octiles, you arrange the data by ascending order or descending order of magnitude. So here I taken ascending order. So lowest to highest, that is 20, 28, 40. So 12, 15. Now arrange the data in ascending order: 12, 15, 20, 28, 30, 40, 50. Now Q1 is equal to size of n plus 1 by fourth item. So here the written capital letter N. So you should write only small n. Why? Because individual series. When you are having individual series, you can take the small n. When you are given frequency distribution, you should take the capital N. Already I explained in detail before class. Now size Q1 is equal to size of the n plus 1 by fourth item. So that is size 7. Similarly, size of 3 into 8 by 4, the sixth item. So in the ascending order, you should have sixth item is 40. Now quarter see, so the net is going and coming, it is fluctuating. So Q3 is equal to 40. Now quarter deviation, that is Q3 minus Q1 by 2, that is 40 minus 15 by 2 is equal to 12.5. Now coefficient of Q is equal to Q3 minus Q1 by Q3 plus Q1. So 40 minus 15 by 40 plus 15 is equal to 0.455. So this is the coefficient of range, coefficient of quartile deviation. This is the only for quartile deviation. Only for quartile deviation, nothing but absolute measures of dispersion. Coefficient of quartile deviation, nothing but relative measures of dispersion. Now coming to discrete frequency distribution, calculate quartile deviation and its coefficient for the following data. Okay, now see the problem. Solution: marks 10, 20, 30, like so on and so forth. Number of students 4, 7, 15, that is capital N equal to 43. You can check it whether it is correct or not. Now first 4, next to 4 plus 7, 11. So that is you should get 43. So here the value, this is value. So this is 43. So 43. So this value equal kavala. So do the problem, check the table. Okay. Are doing? Anybody response?
Yes, sir.
Yes, sir.
Do it. Clear? Table is correct. Solution table is check it whether it is correct or not. So in that Q1 equal to size of n plus 1 by 4th item. So size of n is equal to 43 plus 1 by 4th item, that is 11th item. So in 11th item, you will see the cumulative frequency distribution. So here you can see 11th item. So 11th item in between, here is there 11th item. So 11, that is 20 is the value. That is Q1 is equal to 21. Okay. Now, if you are not understanding this solution, again you can see for Q3. Q3 is the size of 3 into n plus 1 by 4th item. The size of 3 into n plus 1, that is 43 plus 1 means 44 by 4. That is 33 item. 33 item you can check in CF. In CF 33 item. So that is here. So 34. So 4 lo 33 undadu, 11 lo 33 undadu, 26 lo 33 undadu, 34 lo 33 untundi kabatti that is the 40 is the Q3. Q3 is the 43. Q1 is 20. Q1 is 20. Now coming to quartile deviation, Q3, QD is equal to Q3 minus Q1 by 2. 40 minus 20 by 2 equal to 10. So here is one mistake is there. This Q3 equal to 40 coming to the here Q3 is equal to 40 come in the here. Okay. Now then next quartile deviation QD is equal to Q3 minus Q1 by 2. 40 minus 20 by 2 equal to 10. So coefficient of QD is equal to Q3 minus Q1 by Q3 plus Q1, that is 40 minus 20 by 40 plus 20, that 20 by 60, that is 1 by 3 equals 0.333. So this is discrete distribution. Clear? Any doubt? Tell me. Give the response.
Sir, inko explain cheyandi.
Inkokasari. Okay. 1 minute. Here you can see Q1. The formula is size of 1 into 1 means what? Q1. 1 into n plus 1 by 4th. That is size of 1 into 43 plus 1 by 4. So 43 is the total frequency plus 1 by 4. That is 11th item. 44 by 4 is 11th item. Okay. Now you can see in the CF. In the CF, where is 11? Here is only 4. In CF, here is 11. So the corresponding value is 20. Mark is 20. That should be known as Q1. Okay. Now Q3 is equal to size of 3 into n plus 1 by 4 item. Size of 3 into n plus 1, that is 44 by 4 is equal to 33 item. So in CF, we see 33 item. So 4 lo 33 undadu. In 11 we should not having 33. In 26 we should not having 33. In 34 we should have 33. So that corresponding value is 40. Mark is 40. That Q3 is equal to 40. Isn't it? Now Q3 equals 40, that is the formula, and substitute and simplify it, you should get answer. Give the response. Be fast. Now coming to continuous frequency distribution. The following is the range. The following is the age distribution of 799 workers. Age group 20 to 25, 25 to 30, 30 to 35, 35 to 40, 40 to 45, 45 to 50, 50 to 55, 55 to 60. So this is known as continuous frequent distribution. Corresponding number of workers in 2025, number of workers is 50. In 25 to 30, number of workers 70. Find QD and its coefficient. You find the QD means it is the absolute measures of dispersion. Find its coefficient means you can find the relative measures of dispersion. To find QD and its coefficient, we first find the value for Q1 and Q3 for the given data. Now, first of all, you can construct CF. Here is 50, 50 plus 70, 120, like you should get the value. So this is 799. Equal kawali. 79 to 79. 799, 79 equal kawali. Do it. Over. Yes, please. Over. Give the response, anybody?
Yes, sir. Completed.
Right.
సార్ క్వార్టల్ డిస్పర్షన్ ఫార్ములాస్ డిస్క్రీట్ కి వేరే గానీ నెక్స్ట్ కంటిన్యూస్ కి వేరేగా ఉంటుందా సార్?
Okay. Right. So Q1 is 0.75. This 119.75 lies in between 220. So that 30 to 35 is the interquartile class. 30 is the lower limit. Corresponding frequency is 100. CF is 120. Now take the formula, that is Q1 is equal to L plus N by 4 minus CF by F into H. This is the formula for Q1. Already explained in third unit to fourth unit we explained before class. So Q1 is equal to L1 plus N by 4 minus CF by F into H. Now substitute the values and simplify. You should get Q1 is equal to, that is Q1 is equal to 33.99. That nothing but 34. That 34 years. Take the approximation. Now you can see Q3. Q3 is the value of 3 into N by 4th item. So 3 into N by 4th item. 3 into N by 4th item. So 3 into 799 by 4, that is 599.25 item, which is lies in between 45 to 50. So here you can see that is 599. So value 599 means lies in between here. You can see 400, 550, 670. Lies in between 670. That's 599. 599.25 lies in between 670. So the corresponding interquartile class 45 to 50. So L3 is equal to 45, H is equal to 5. The frequency is 120 and CF is 550. And take that values and substitute in this equation. That is Q3 is equal to L3 or L, you should write, plus 3 into N by 4 minus C by F into H. So substitute all the values. You should get 47.05. That means nothing but 47 years. Now coming to QD, Q3 minus Q1 by 2, that is 6.5. Coefficient of QD, that is Q3 minus Q1 by Q3 plus Q1, you should get 0.61. Okay. Now solve it. If you are having any doubt, tell me. I will explain. I will clarify your doubts. Solve it. Do the problem.
Sir, in formula F is there, sir?
F nothing but corresponding frequency.
Correct.
Which is having interquartile class. The corresponding frequency is the F. H is nothing but width of the class interval. C nothing but cumulative frequency. L nothing but lower limit of the interquartile class. Lower limit of the interquartile class. Okay, clear? First of all, you can find Q1. Then after you can find Q3. Then after you can substitute QD is equal to Q3 minus Q1 by 2. Then after you can find relative measures of dispersion, coefficient of QD. So here is exercise problems are there. First problem is individual series. Second problem is discrete distribution. Third problem is continuous frequency distribution. Do the problems on page number 76. Now coming to mean deviation. Here is their mean deviation, MD. Previously we have studied range and quartile deviation, which are the positional averages, positional measures of dispersion. These are two, which is having range and quartile deviation are known as positional measures of dispersion. their computation is not based on all the observations. In strict sense, they are measures of dispersion as they do not measures of scatteredness in observation. Scatteredness means dispersion, how the variables are dispersed, whether it is less dispersion or whether it is more dispersion. So dispersion, in literally dispersion means scatteredness of the variables. Mean deviation of a series is the arithmetic mean of the absolute deviation of various items from some central value, such as mean, median, and mode. Symbolically, the mean deviation about mean deviation about median, or mean deviation about mode can be expressed as follows. So here you can just write the formulas. Mean deviation from mean, mdx bar is equal to 1 by small n. Here given the small n, here is given capital N, but you should write small n. 1 by small n, sigma x minus x, sigma modulus x minus x bar. Mean deviation about median, that's MD median is equal to 1 by small n, sigma modulus x minus median. Mean deviation about mode, that is mean deviation about mode is equal to 1 by small n, sigma modulus x minus mode, where n is the number of observations. You should write small n, where n is the number of observations. Now, sigma modulus x minus x bar is the sum of the absolute deviation taken from the mean. Sigma modulus x minus x median, sum of the absolute deviation taken from median. Summation modulus x minus mode is the sum of absolute deviation taken from the mode. In case of grouped frequent distribution, with the above formula can be recognized. Here you should not have frequency and you should not have capital N. But whereas in frequent distribution, mdx bar is equal to 1 by capital N sigma f into modulus x minus x bar. Where you should have f, you should write capital N. Where you should not have f, you should write small n. That is the difference between individual series and grouped data. MD is equal to
small n ga.
Small n తీసుకోవాలి. ఇండివిజువల్ సిరీస్ లో టెక్స్ట్ బుక్ లో క్యాపిటల్ పడ్డది, ఆ క్యాపిటల్ ప్లేస్ లో స్మాల్ n తీసుకోవాలి ఇండివిజువల్ సిరీస్ లో. బట్ వేరే ఫ్రీక్వెన్సీ డిస్ట్రిబ్యూషన్ లో క్యాపిటల్ తీసుకోవాలి. క్యాపిటల్ వచ్చిందంటే ఇక్కడ ఫ్రీక్వెన్సీ వస్తుంది, ఇక్కడ స్మాల్ n వచ్చిందంటే ఇక్కడ ఫ్రీక్వెన్సీ ఉండదు. ఇక్కడ ఫ్రీక్వెన్సీ లేదు కాబట్టి స్మాల్ n, ఇక్కడ ఫ్రీక్వెన్సీ ఉంది కాబట్టి క్యాపిటల్ n. దట్ ఇస్ ద డిఫరెన్స్ బిట్వీన్ అన్గ్రూప్డ్ డేటా అండ్ గ్రూప్డ్ డేటా.
Okay.
Mean deviation about mode is equal to 1 by n sigma f into modulus x minus mode. Okay. Now coming to coefficient of mean deviation. Coefficient of mean deviation, the formula mean deviation is an absolute measure of dispersion. The corresponding way to measures are called coefficient of mean deviation. It is denoted by dividing mean deviation by the average or central value used for calculating it. Okay. 1 minute. Okay. Okay, right. So coefficient of MD is equal to mean deviation by mean or median or mode. By mean or median or mode. Okay. Example. Compute mean deviation and its coefficient from the following data: 10, 70, 50, 53, like so on and so forth. Okay. Integer series is given. You should take x here. X values, absolute deviation from mean. So 10, 70, 50, like you can write sigma x is equal to 583. Now mean is equal to sigma x by n. Here given capital N. So you should write small n. Here you should write small n. Here you should write small n. Sigma x by small n, 583 by 11 items are there, 53. So modulus x minus 53. Absolute deviation from mean. That means modulus x minus 53. So 10 minus 53. 10 minus 53, that is minus 43. When you are taking modulus, it is 43. Okay. Now next, see, 70 minus 53 means 17. Modulus 17. 53 అనుకున్నాం కదండి మీన్ వాల్యూ. ఇక్కడ ఇవ్వండి, ఇక్కడ స్క్రీన్ పై చూడండి మీన్ ఉందా. ఇక్కడ ఏమడిగిండు అబ్సల్యూట్ డీవియేషన్ ఫ్రమ్ మీన్ అన్నాడు, అంటే మీనే అనుకోవాలి. అబ్సల్యూట్ డీవియేషన్ ఫ్రమ్ మీడియన్ అంటే మీడియన్ అనుకోవాలి. absolute deviation from mode అంటే మోడ్ అనుకోవాలి. సో మీన్ డీవియేషన్ లో we should have 3 categories, that is mean or median or mode. You can find 3 formulas. Mean deviation about mean, one formula. Mean deviation about median, second formula. Mean deviation about mode, third formula. Here I am doing mean deviation about mean. So that's purpose. That purpose we can calculate average 53. So now modulus x minus 53. So sigma x minus x bar is equal to 190. You can check it. You can calculate these values and check it. It is 190. Now our formula is mean deviation about mean is equal to 1 by n. So this is small n. This is small n. Okay. 1 by small n summation modulus x minus x bar is equal to 1 by 11 into 190. So that is 17.27. The value is 17.27.
Sir, in formula x value is?
X value
is 53. X value?
1 minute. X is given 10, 70, 50, 53.
Yes, sir.
The values is given. So x is equal to 10. 10 minus 53. Minus 43. Minus 43 modulus means what? Modulus means what? If you are having negative sign, it will come to positive. It will having positive modulus, it is also positive. Where you should have minus, you should take deviations, absolute deviation. So modulus 10 minus 53 equal to 43. Modulus 70 minus 17, that is modulus 70 minus 53, that is 17. Like you can calculate. So in this, first of all, you can calculate mean value. Then takes absolute deviation from mean. Now here, see, the question is compute mean deviation about mean. And undala clear akkada. Question lo chudandi, compute mean deviation about mean ante ee process and its coefficient from the following data. Now going to second problem. See, second problem, compute mean deviation about mean. Compute mean deviation about mean. Compute mean deviation from the mean for the following data. So 2, 4, 6, 8, like so on and so forth. Here you can see solution. X is equal to 2, 4, 6, 8, 11, 10, 12, 14, 16. F is equal to is given. Fx modulus x minus x bar. F into a modulus x minus 8. So here is 8. So sigma x by n. Sigma x by n. That is 160 by 20. 8 is value is there. So 8 subtracted. Absolute disturbance cheyakandi. You should not go to disturbance. Absolute deviation from mean, that is f into modulus x minus 8. Similarly, you can calculate the mean deviation for the following data. Here, calculate the mean deviation from the mean, and padala akkada printing mistake, from the mean for the following data. Also find the coefficient of mean deviation. So this is CI, mid values Fx, mean value is 51.07, like calculated. So here is the examples are there. Calculate mean deviation and find its mean. Find its coefficient for the following data. So here you should take screen. Okay.
Sir.
చెప్పండి.
Sir, solution పైన కంప్లీట్ దీది సార్ మీది ముందు ప్రాబ్లం సార్.
పేజ్ నెంబర్
మోడల్ ఆఫ్
ఓకే ఇక్కడ
మోడల్ ఆఫ్ x minus x bar is equals to మోడల్ ఆఫ్ x minus 8. మోడల్ ఆఫ్ అది ఎట్లా వస్తుంది సార్ వాల్యూస్?
మోడల్ కాదు, మాడ్యులస్. మోడల్ కాదు మాడ్యులస్. ఇదా స్క్రీన్ మీద కనిపించండి.
ఎస్ సార్, అదే సార్.
ఇది ఇప్పుడు క్వశ్చన్ లో ఫైండ్ మీన్ డీవియేషన్ ఫ్రమ్ ద మీన్ అంటే ఈ ప్రాసెస్.
ఎస్ సార్.
ఫైండ్ మీన్ డీవియేషన్ ఫ్రమ్ మీడియన్ అంటే మీడియన్ కనుక్కొని చేయాలి. ఫైండ్ మీన్ డీవియేషన్ అబౌట్ మోడ్ అంటే మోడ్ కనుక్కొని చేయాలి.
ఓకే సార్.
టెక్స్ట్ బుక్ లో మీన్ డీవియేషన్ ఫ్రమ్ మీన్ అనేది చేసిండు అంతే. కాబట్టి ఇక్కడ మీన్ ఏంటిది, ఇక్కడ చూడండి మీన్ వాల్యూ మనకు చూడండి సిగ్మా ఎఫ్ఎక్స్ బై ఎన్ వచ్చింది. సో 120 ఎక్స్ వాల్యూస్ ఈజ్ గివెన్, ఎఫ్ వాల్యూస్ గివెన్, ఎఫ్ఎక్స్ చెప్పినాం మీన్ వాల్యూ సెంట్రల్ టెండెన్సీ లోపల సిగ్మా ఎఫ్ఎక్స్ బై ఎన్ చెప్పినాం. సో 160/20 వేస్తే 8 వస్తుంది. ఈ వచ్చిన 8 ప్రతి వాల్యూని తీసేయాలి. 2 - 8 మాడ్యులస్ 2 - 8 ఈక్వల్ టు 6. మాడ్యులస్ 4 - 8 ఈక్వల్ టు 4. మాడ్యులస్ 6 - 6 ఈక్వల్ టు 0. 6 - 8 ఈక్వల్ 0. 6 - 8. మాడ్యులస్ 8 - 8 ఈక్వల్ 0. మాడ్యులస్ 10 - 8 ఈక్వల్ 2. వచ్చినాయా? వచ్చిన తర్వాత ఎఫ్ ఇంటూ మాడ్యులస్ x - x బార్ ఇవి ఇవ్వాలి. చేసిన తర్వాత ఫార్ములా ఎక్కువ ఉండండి. మీన్ డీవియేషన్ అబౌట్ మీన్ ఈక్వల్ టు 1/N స్క్రీన్ పైన 1/N సిగ్మా ఎఫ్ ఇంటూ మాడ్యులస్ x - x బార్. సో సిగ్మా ఎఫ్ ఇంటూ x - x బార్ ఈక్వల్ టు 56. 56/20 ఈక్వల్ 2.8. ఇట్లా ఈ ప్రాబ్లం. ఓకే, సో ఇక్కడ కంటిన్యూస్ సిరీస్ లో మళ్ళీ ఈ ప్రాబ్లం చేయండి. ఇది ఒక మోడల్. ఇది చేసిన తర్వాత ఇక్కడ చూడండి కోఎఫిషియంట్ ఆఫ్ మీన్ డీవియేషన్ ఈక్వల్ టు మీన్ డీవియేషన్ బై మీన్ ఈక్వల్ టు 14.42/51.07. ఓకే, 14.42/51.07 ఈక్వల్ 0.28. ఇది ఓన్లీ ఫర్ ఈ 3 ప్రాబ్లమ్స్. డిస్టర్బెన్స్ అవుతుంది, డిస్టర్బెన్స్ కానివ్వకండి. ఎస్ ప్లీజ్ డియర్ స్టూడెంట్స్, డోంట్ గో టు ద డిస్టర్బెన్స్. ఈ 3 ప్రాబ్లమ్స్ మీన్ డీవియేషన్ అబౌట్ మీన్ మాత్రమే చేసినాం మనం. ఇవే ప్రాబ్లంకు ఇదే డాటాకు యూ కెన్ ఫైండ్ మీన్ డీవియేషన్ అబౌట్ మీడియన్. మళ్ళీ 3 ప్రాబ్లమ్స్ వస్తాయి, ఇండివిజువల్ సిరీస్, డిస్క్రీట్, కంటిన్యూస్. మళ్ళీ ఇదే డాటాకు యూ కెన్ ఫైండ్ మీన్ డీవియేషన్ అబౌట్ మోడ్, ఇండివిజువల్ సిరీస్, డిస్క్రీట్ సిరీస్, కంటిన్యూస్ సిరీస్. మొత్తం 9 ప్రాబ్లమ్స్ వస్తాయి. ఇక్కడ మనం టెక్స్ట్ బుక్ లో ఎగ్జాంపుల్లో 3 ప్రాబ్లమ్స్ చేసినాం మనం. ఆ 3 మీన్ ద్వారా చేసినాం, మిగిలిన 3 మీడియం ద్వారా చేయాలా, మిగిలిన 3 మోడ్ ద్వారా చేయాలి. ఇంకా 6 ప్రాబ్లమ్స్ చేయాలి. కానీ టెక్స్ట్ బుక్ లో చేయలేవన్నీ, టెక్స్ట్ బుక్ లో అవన్నీ చేయలేడు, చేయాలా. ఓకే, ఎనీ డౌట్ చెప్పండి.
నో సార్.
ఇక్కడ వరకు క్లియర్ అయిపోయింది. ఓకే, నెక్స్ట్ సో స్టాండర్డ్ డీవియేషన్. నెక్స్ట్ టుమారో విల్ డిస్కస్ స్టాండర్డ్ డీవియేషన్ ఇన్ డీటెయిల్. ఓకే, 1 minute, wait for 1 minute. Okay, so remaining tomorrow we can discuss. Okay, up to here that is range, quartile deviation, mean deviation. These are 3 topics are completed for this session. So tomorrow remaining topics we will continue. Okay, now bye.